This topic tends to be really difficult for a lot of students, so I wanted to make sure that I gave you ample practice where you had the solution so that you could do the question and then check your solution with mine. So here are 4 questions for you to practice. And notice that I did not specify on each question whether we're dealing with a proportion or dealing with a mean. So what I'd like you to do is press pause. And yes, there are 4 questions, and some are easier and some are harder, but I want you to press pause. I want you to first just write down if it's a mean or if it's a proportion, and then press play, and I'll go through that first, and then I'll have you press pause again to try the questions. So hopefully you did actually press pause, cheaters if you didn't, but let's take a look. First one, M&Ms are sold to 40% of candy buyers at the Candy Hut, and we have a sample of 300 candy buyers. So this tells me that this is a proportions question because I'm dealing with a percentage of candy buyers. Number 2, the mean weight. Right away I should have said, hey, that's an average. So the mean weight of US men is 190 pounds. This is going to be a means question. Number 3, 74% of college freshmen at Bray Mu make it to their sophomore year. So 74%, that's a percentage, that's a proportion. And last one, 200 randomly chosen 18-year-old women reported a mean weight. Mean means average, which is a means question. So hopefully you got that far. Now what we're going to do is you should just press pause and try all 4 questions. Just do them all. Yes, it should take you a while because you should check the conditions for each one. You should do the calculations for each one. You should plug whatever is necessary into StatCrunch for each one. You should write a conclusion for each one. So once you have tried as many as you will try, hopefully all 4, then I want you to press play to see how you did. So my first question is the M&Ms question, and again it says M&Ms are sold to 40% of candy buyers. That's P. That's what I'm expecting to see. Sample of 300, that means N is 300. Candy buyers from the Candy Hut is surveyed. What is the probability that no more than 20%? 20% is P hat. And no more than 20% gives me that I'm going to be dealing with the fact that X is less than or equal to 0.2 when I'm finding my Z-score and the probability and all of that. So then I check my conditions. Random. It isn't stated, but we'll assume the buyers were chosen randomly because again it says they were surveyed, and so we're assuming that a survey is going to follow all the rules of a survey. 10%, we will assume 300 candy buyers is less than 10% of candy buyers, or I can say assuming, assuming at least 3,000 candy buyers. Because we don't really know for sure, but we're assuming if their sample is 300, then they probably are doing pretty well and have more than 300 customers. Independence, whether or not a customer buys M&Ms is independent of other customers buying M&Ms. And success, fail, N times P, N times Q, they're both greater than or equal to 10. So because the conditions are met, my mean is going to be P. My standard deviation is going to be the square root of PQ over N. And so notice I've just separated those 2 values with a comma and then actually computed the 0.0283 for my standard deviation. For a picture, on this one it's completely optional, but I know I'm expecting 40%. I observed 20%, and I'm finding 20% or less because it says no more than. For my calculations, that's going to be my Z-score. So Z is observed of 0.2 minus expected of 0.4 over the standard deviation that I've already calculated. And then I'm going to go over to StatCrunch and notice, and we haven't had one of these before, but looking at this, this is a really low Z-score. We've talked about Z-scores and how we expect 99.7% of our Z-scores to be, within -3 to +3. So if I'm looking at -7 or less, does it make sense that I get this number, or what does that number even mean? Well, this means that it's 76855, and the decimal goes 13 places to the left. 1, 2, 3, 4, 5, you get the idea. 13 places, so essentially I have 12 zeros in here. So what does that tell me? That it's essentially 0, because that's a really stinking small number. So what's my conclusion? According to the normal model, in a sample of 300 candy buyers, no more than 20% purchase M&Ms is essentially 0. That brings us to our next question. This one we already said is going to be a means question. And so the first thing I'm going to do is check conditions. And the conditions say random, again, not stated, but we're going to assume that these men that are on the elevator are representative of the population. So how do I know that? Well, unless the elevator is like for the men's big and tall store, we're going to assume that people getting on the elevator are fairly representative of the population. 10%, 10 is less than 10% of all men. Independence, the weight of the men on the elevator is independent from one another. Large enough, though our sample is smaller than 30, again, weight is normally distributed. And then because weight is randomly distributed, I'm going to use the normal model. And the normal model is my mean of 190 that was given to me, and my standard deviation of 59 pounds divided by radical n, and radical n would be radical 10, so here's my normal model. Now, in terms of the picture, again, I'm actually testing it against some other score, and so my picture is not the empirical rule, it is helping me to determine which direction to go for my z-score. So I'm expecting 190. Where did this 250 come from? This is the hardest question because I just threw something at you to see if you knew what to do with it. I know that the weight limit of 10 persons is 2,500 pounds, and so I'm going to say that I'm observing an average of 2,500 divided by 10 people, which means each person or each man on the elevator on average could weigh up to 250 pounds and we'd still be okay. So what are my calculations? Again, I'm using my observed of 250, which I got from up here, minus my expected, which was given to me, divided by the standard deviation, which I computed by taking 59 divided by radical n. I plugged that into StatCrunch to find my answer. Don't say this is essentially 0 because it's not. If I move it 2 decimal places, it's 0.065. So it is a very small number, but that's okay. It's not essentially 0. It's saying there is about a 0.07% chance that a sample of 10 men will overload the weight limit. So it's very, very small, thank God. Next question deals with college freshmen and a sample from Brame U. 74% of college freshmen make it to their sophomore year. So again, that is what we are expecting. That's a P because it's a proportion. We take a random sample of 400 freshmen. That's N. They're saying, using the empirical rule, what might we expect to see? So empirical rule is explicitly given to us in this question. So I would check the conditions. 400 was taken randomly, or were taken randomly. 400 is less than 10% of all freshmen. Independence, whether or not a freshman is successful, is independent of other freshmen, again because we're choosing a random sample. And success fail, they're both greater than or equal to 10. Calculations, 74% given to me. Standard deviation, I have to compute PQ over N. Remember, Q is not a secret, it's just 1 minus P. 1 minus 0.74, which is 0.26. That's where I got these numbers. So PQ over N, and then the square root. Don't forget the square root. That gives me a standard deviation of 0.0219. And that means I'm using the normal model, 0.74, 0.0219. Then I'm going to use that 0.0219 to add as I move to the right, subtract as I move to the left. I can always plug it into StatCrunch as well to help me find those values. And then my conclusion, and then I'm just giving you the values. So according to the normal model, etc., 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 etc. Now for our last question, we have 200 randomly chosen 18-year-old women. 200 is N. That is our sample size. They reported a mean weight of 140 pounds. So if we actually look at the question at the end, which we might use a z-score for or maybe not, this would be my observed value of 140. But we are given the mean and the standard deviation of the population, and that's all we're typically given when we are finding the empirical rule. And so in this case, it asks us to use the empirical rule. So we're going to ignore the 140 for a little bit. We're just going to look at the empirical rule. So we're going to check the conditions. So 218-year-old women were chosen randomly. We're given that information. For a large college, or in this case, does it really matter if it's a college, we're looking at 18-year-old women. That sample is less than 10% of all 18-year-old women. Independence, women's weights are independent of one another, and our sample is at least 30, and also we already know that weight is a normally distributed variable. So we're okay. Calculations, for my empirical rule, I'm using a mean of 143.74. And my standard deviation, I'm going to use the 51.54 that I was given, but I have to divide it by radical n, because n is my sample size, and that was 200. So this is the standard deviation for my sample. And again, now I'm just going to draw a picture. And when I draw a picture, I'm starting with my 143.74 in the middle. I'm adding that 3.644 as I go to the right and subtracting as I go to the left. And if I were just asked to use the empirical rule, I would be done and I would say 68% of the time I expect between this and this, etc. But this one has an extra little fun nugget in here that says, comment on whether 140 pounds seems unusually low. So where is 140 on my picture? It's like right here. It's just to the left of one standard deviation. So am I surprised by that? No, I'm not surprised by that because it's low. It's lower than the mean, but it's not that unusual because it's essentially within one standard deviation, which 68% of my values are.